Beyond the Wrench with Jay Goninen from Find a Wrench.
All right, I say this a lot, but I am really, really excited for today's guest, an industry leader in a bunch of different ways, has a lot of different projects he's working on, his hands in a lot of different things, and truly is an industry leader. And I'm really proud and happy to have Scott Brown join me today. Scott, how are you?
Hey, I'm great, Jay. Thank you for having me.
So how did you get to this point? I mean, you've got a lot of things going on, but I have to start by asking what got you into this industry in the first place?
Well, looking back, it is amazing, an amazing journey. Out of high school, first, I guess I go back to high school. We were not allowed to go into auto shop until we were in our junior year, but somehow I bribed somebody and I got in as a sophomore. And so I had 3 years of auto. And then when I graduated from high school, I went to tech school, moved out of state, went to tech school, and then came back, started working in the independent sector. And that was in the early 80s. That was 1983. And at that time, I noticed that, we started seeing computers being deployed on brand new cars. That became more mainstream. And the first thing I observed was that most technicians that were around me, the seasoned technicians, really didn't want much to do with those. They were kind of shunning them, and I saw that as an opportunity. So I did everything I could to begin learning everything about computer controls. The shop I was working in was actually related to AC Delco, and we had access to the GM training center down in Los Angeles. So I started talking to my boss at the time and said, hey, I want to start going to these day classes. And, he said, oh, well, that's during the day. And by the way, you can go to class, but, you're not going to get paid. And, it was really kind of a weird thing. And I said, well, I need to get some knowledge and education. I need to learn this new stuff. I think we eventually came to terms where I did get paid for going to school, but that was a pretty tough deal there. That's one of the things that I saw as a kind of a negative in our industry. But over the years, I started participating pretty heavily in the industry at many levels, participating with trade organizations. We have one here in California called the Automotive Service Councils. Our shop that I was, working at was a member of the Automotive Service Councils, and I was, again, asked by my boss to go to these monthly meetings. And, I was a young kid at the time, and all the attendees were these older shop owners. And I felt very uncomfortable, but they made me very comfortable right out of the gate, and I started making a lot of relationships there. And around 1989, I got approached by a shop, the two owners of the shop that I own today, my wife and I own, Connie and Dick's. They came to me and they said, hey, we're going to retire and we want to sell our business to you. And at first I thought I thought they just wanted to get me to come to work for them. And I thought that was really not a true offer. But it really was. I took them up on the offer. I came in, bought the business, bought the building, the property. When I got to this business, we had one small little office with no windows, no waiting room, no lifts, hardly any, not much tooling and equipment. And I saw an opportunity. I had already been using computers for service information and shop management, and we had none of that here. So I essentially had somewhat of a clean sheet there. And so I began investing heavily in this business. And at that same time, I got into computers and networking. And this was before the internet. And I established a bulletin board system, and I was engaging with other technicians. I was using other online services like CompuServe. And then when the internet came around, I met a gentleman by the name of Brent Black who had started this AutoTechNet group, and it was more of a mailing list, and then that's what really became the IATN group. And I basically started focusing all my efforts with him on the IATN group, and that just blossomed into a very large enterprise, and that is where I left that enterprise in 2018, and then started the Diagnostic Network platform, as I saw a need really for focusing on the high-level diagnostician. Because of the layers of technology being applied to the automobile, the diagnostics is really where I feel the front line is, because if you're not able to diagnose what's going on with the automobile, you're really not going to be able to do the other services that the vehicle is going to require. And so that's where we're at. And in between there, I've done a lot of education, and so I've been doing, I've diversified myself quite a bit, and doing a lot of education, a lot of video type training, and so on. And so this is where we're at, and I'm very passionate about what this industry is all about. The industry has given me a lot, and I intend to give a lot back to the industry as well.
And you already have. You've already given so much back, and I think just in terms of the value in the content that you provide, and having the kind of the foresight to see these different opportunities is incredible. One of the things that I would ask is, how do you manage this? How do you, all of these different buckets you have, how do you, and granted, I think they all kind of play together, but how do you manage your schedule?
Yeah, that's a tough one. I am actually in a pretty good spot here. I have a very good team of individuals around me that know what to do. We've got systems and processes in place. For instance, my shop, this is where my office is. I have an office, a studio here. My folks know how to run the business, and we meet all the time, but they handle the day-to-day operations. I'm involved in the business, but more on some of the diagnostics type stuff, so that I'm seeing real world stuff all the time. On the Diagnostic Network side, we've got still a very small operation, so we've got some key individuals that are continuing to develop and push the envelope on that platform. And then as far as my knowledge, I'm always absorbing and consuming content and learning. I mean, I'm a lifetime learner. I think that anybody that wants to get ahead in this industry has to become a lifetime learner and engage in what's called micro learning, where you're picking up pieces, you're learning through networking, and that's where basically the networking through IATN or Diagnostic Network, you're exponentially growing your knowledge base through the experience of others, and in turn you're reciprocating by giving back as well. So yeah, so it's pretty awesome, and really it's the passion, right? You look at the automobile, the modern automobile, it is a giant experiment, a project, right? It's a science project that actually works and has a lot of science, technology, engineering, and math. This is what they're trying to teach in schools, and there's huge opportunities out there. So that's what gets me excited, and especially around the automated components that are being applied to automobiles today. So that's kind of where my strong focus is now, on educating on those new technologies, because they're coming.
Well, and I think that segues very nicely into our subject for the day, which is really around the evolution of the modern day automobile. Some of the technology that's coming is coming at such an insanely fast pace that I think there's a lot of technicians and a lot of shops that are terrified of this, right? Because it is changing by the day. And so what I'd like to do today is kind of try to break this down into bite-sized pieces a little bit for everybody, so that maybe we're not as intimidated by the upcoming technology, and really being able to for those managers out there, put together a plan of what the future looks like, and those technicians really to be able to put together some level of ability to grasp this and understand it and not run from it. Because I think you hit on one point that I think was key early on in your career, was that you wanted to take on that challenge. You wanted to go after that technology, and it's really, it's paid off for you in how your career has progressed. So I think this would be a fascinating thing to really pick your brain on today. And so let's start with that. I mean, the future of the industry in general, obviously, I think I read, I don't know, a couple of weeks ago that 10% of new vehicle sales currently are either hybrid electric or battery electric vehicles. And so the days of just thinking that this is a flash in the pan type of thing are gone. Like, it's here. It's the systems are here, and I don't think they're going to get less complex as we move forward, right?
Yeah, yes and no. I mean, if you look at the electrified, if you look at a completely battery electric vehicle, there are less parts. I mean, we get them in the air here, and you look underneath these cars, and they're very complicated, right? You've got a fuel cell, you've got all this evaporative collection components, you've got fuel lines, you've got other components on the vehicle, like the exhaust system, engine mounts, and on and on and on. After treatment systems, catalytic converters, right? Catalytic converters are getting stolen a lot.
Yeah.
A lot of complexity going on there. The battery electric vehicle, what you got? A battery, you have a traction motor, electric motor. You've got some microcontroller devices to control the electric energy flow, to the motor and back. And then you've got some of your vehicle electronics, your 12-volt system. So, in some sense, they're actually simpler. You also look at the braking system, on these cars. If the car is being driven properly, the vehicle brakes are not being exercised the same way that a regular car is. And so, you've got less wear going on there. But then you've got, on the flip side there, you've got, certain regions of the country where there's a harsher environment, where you have a lot of snow or what have you. That could play havoc on a brake caliper, where it doesn't get exercised, and then all of a sudden it's sticking, right? The sliders are sticking or what have you. And if you go to exercise that brake could stay applied. So there are things there to look for. But I think that, the battery electric platform is somewhat more simplified. Although, because it's different technologies, it's going to look complex on the outside until technician gets their head wrapped around the technology and understands what's going on. But once you've driven these, and I drive one every day, I drive a battery electric vehicle, and I'll tell you, it is so nice to be able to drive something that's very smooth, has very clean torque, linear torque, and instant torque, right? You want to get on the freeway, there's no lag. It's instant, and it goes, and it's nice and quiet and smooth. Every ICE car that I get in, when I'm driving it, the first thing I notice is how much the engine moves around, and I go, wow, I think this one's got excessive movement in the engine mount. So I'm a little hypersensitive on that part. But yeah, it is. I mean, there's a contrast there, and still, if you look at it from the big picture, the high level, our fleet in general, it's only about 3% of the car park out there is electrified today. But if you're in certain regions, like we're here in California, of course, that's a much higher percentage, primarily due to our climate, due to local incentives, to get those vehicles into the pipeline. So I think there's going to be a big future for battery electric and hybrid electric vehicles.
Well, and you're not kidding with the drivability of one. I think I was skeptical even up to probably a year ago, just based on some of the stuff I had driven in the past, and not even skeptical about the drivability, but more skeptical about the sustainability of a battery operated vehicle. But I've got one of my best friends drives a Tesla, and I hopped in and drove that one day, and it just blew my mind. I mean, it was the acceleration, the just performance in general, and how simple the interior was. I mean, just they've done such a good job in developing that, and I think, similar to any other generation, there's going to be evolution, and I think this is the next evolution. And it's funny that you say that with the driving an internal combustion engine vehicle versus a battery electric vehicle, and how it kind of sways your brain a little bit to like, oh my goodness, there's a little bit of vibration there. But I think that in itself is one of the challenges that shops look at, right? Is how to allocate resources, whether it be training or tooling, and how, when you look at maybe a modern day internal combustion engine, and then that this thing is coming, there's this electrification of cars is rapidly coming, and especially with all the manufacturers kind of checking into the thought of, we're switching all of our vehicles over to battery electric vehicles. How does that, from a shop manager standpoint, be able to, how do you grasp that? Like, how do you make sure that you're tackling the current day stuff while you're putting together a plan for some of this stuff that's coming?
Yeah, I think that the strong focus should be placed on the fact that recognize that platform is software driven. There's a tremendous amount of software that's driving the electronics on board, the power electronics, and you need to have your technicians thinking like software engineers. They need to have some level of understanding of how program and code can run, and sometimes not run, right? Or bugs show up or weird things start to happen, because that's when something fails and some weird failure modes start to occur. That's when the diagnostics become very fuzzy. And if you have that computer flow, failure modes, understanding, that's going to help you get your head wrapped around what to look for. A lot of the diagnostics that we are provided, when you subscribe to even the OEM service information, they're walking you down a pathway, but they're not necessarily telling you exactly why you're there and what you're testing and what you're looking for. Most technicians that I know like to know why they're there, what they're looking for, and then they like to establish their own test plans, right, to validate what's happening with the vehicle. And the only way that they're able to establish their own test plans is to have high level of knowledge of, well, what does software do? Plus, what are the power electronics? What are the electronics inside of that module? What are they capable of? What are they typically looking for? What do those signals look like? Either to a meter or to a scope. So if you've got a strong suit of technicians that have those skill sets, you're well off in being prepared to handle this next generation of technology that's floating into our car park.
So let's start with tooling first, and then we'll kind of step into the training side. But one of the things that I'm curious in what you see is just trying to understand how many shops truly have the capability and the understanding to use a scope.
That's a subjective question.
Very broad.
Yeah. I've been using, since I got exposed to the oscilloscope back in the late 80s. That opened my eyes huge. I was able to, it's like the visual voltmeter. And there's a lot you can see, and there's a lot of testing you can actually make on a vehicle that can help, that can prevent you from actually taking a dive and taking stuff apart and then going and checking things. You're checking current and so on. But Yeah, I would say it's a very small percentage of the technicians out there in the marketplace that are, you know, very proficient or comfortable in using the scope. Even in my shop here, you know, my techs can use the scope, but a lot of times I see hesitancy in using that scope, and because there's a lot of unknowns. You know, they may have difficulty getting something on the screen or understanding what it is that they're looking at, and that can end up complicating things as well. So it's a difficult call, but you know, in my personal opinion, if you're highly proficient in the use of a oscilloscope and a voltmeter and understand you know, power, ground, power, and electronics, you're well equipped to handle the challenges that are coming at you daily and will be coming in the near future.
Which, one more question on a scope, and it's just, I think this is more of my curiosity in general, but I remember I had worked with a guy that was just great with like an old Sun scope. He knew how to use it, knew how to get it all set up, and was just, I remember thinking to myself, and I was taught this, and it just was from the time that I was taught it until the time that I actually tried to apply it, like everything had gone, right? Like it wasn't sticking with me on how to have the right scale in place, and really making sure that I understood what it was that I was putting the scope on. And so, or why I was doing it in the first place. If you had a tech that wanted to understand how to use a scope better, but maybe didn't necessarily want to do it on company time, or, you know, maybe trying to screw around in the back bay at night, just trying to figure it out. What's a good way to go about that? I mean, is it taking a class first and then going back and using the scope in the shop, or any I guess advice to somebody that's out there that wants to get better with the scope?
Yeah, there are a ton of learning opportunities out there. You know, you can go to, you know, groups like CarQuest, Technical Institute. They offer training. There's Automotive Training Group. They offer training, just basics in lab scopes. And once you get the basics down, then you can continue to chew off more, right? And learn and continue to push your knowledge base up. I think the biggest thing for somebody new, or really anybody, when you go to hook up a scope, you need to know what to expect, right? If I'm going to hook up to I'm going to look at a digital signal that's coming out of, say, a crank sensor. I need to understand, well, what am I going to see? Am I going to see a 0 to 5 volts, or am I going to see a 0 to 12 volts? So that's going to tell you what kind of vertical resolution you want to set your scope at. I mean, in most cases, you just set your scope to 0 to 20 volts, and then you can go ahead and connect and turn the thing on and crank it or whatever, and then you should get something on the screen. Then you're going to have some knowledge of time base, right? Some time domain understanding. So getting your head wrapped around time domain, you know, what the engine operates at, and what to expect. Once you get those two fundamental things down, then you're going to have a good sense of where you're going to establish your base scope settings, so that you can assure that you're going to get something on that screen that's going to make some sense to you, and then you can fine tune from there.
Like that. That's great. That's really helpful. And that's not just for, you know, that's not just for electric vehicles. That's for our current internal combustion engine vehicles. I mean, I think, like you said, I think people forget how complicated our current vehicles are, and being able to use the tools at your disposal is really important. And I know a number of shops that have really, really nice scopes and have the tools to go along with it, and they don't use it. It just kind of sits in the corner, and it's kind of one of those nice to have things that a lot of people in the shop don't know how to use. So, you know, I think for moving forward, that's a pretty big deal.
Yeah, and two, I'd like to add, you know, the scope is definitely a great resource, but I think the other key there is knowing when to use it, when to apply it. Again, with the advancements in software that's being applied to the vehicle, these manufacturers have gone to some great lengths to add diagnostics built into the vehicle. And so when you want to use all the smart technology to help you or help guide you to the fault. So a lot of times you can pull up certain data PIDs with your scan tool and start to look for signs of what it is that you're trying to address, clues that will help guide you down to the component or the system failure that's causing whatever anomaly that brought that vehicle in. So having a keen sense of how to leverage the technology that's in the vehicle and using the right tools at the right time is really where the keys to success is.
So staying on the tooling side, something that you're an expert at and somebody that I think is leading the way for the entire industry on is the ADAS side, right? And being able to see, kind of get out in front of it. How did you start with this, with the ADAS side? I mean, you look at the ADAS tooling at times, I think it can be intimidating with how much it costs, but what's a good way to start kind of getting that understanding of an ADAS system and what tooling you need to be able to work on it, and maybe even to the point of, from a shop's perspective, is this something that I'm going to be contracting out, or is this something I'm going to be keeping in-house?
Yeah, that's a great topic. Where I first got started with this, back in around 2012, I really started looking heavily at this because I bought a new Chevrolet Volt, and this Volt actually had a forward-facing camera on it, and it's classified as a level 0 vehicle according to SAE's J3016 levels of driving automation. And a level 0 car basically just gives you audible warnings for different conditions, whether you're approaching something, an object, or maybe you're drifting out of the lane or what have you. So I started studying what the heck is this thing doing and what's going on. And when I started looking into what are the service requirements for this thing, and I found that there really wasn't a lot of heavy service demand. If you change the windshield out, you're required to do a calibration. Well, on this particular vehicle, and you'll find that this is fairly true for most of the domestic car lines, the camera calibration for that forward-facing camera in the windshield is a dynamic calibration, meaning that you're prepping the car. There's certain prereqs, maybe full tank of fuel, tire pressure correct, and then you're basically connecting a scan tool and initiating a learn, and then you're driving that car in a high target environment. And within 10 or 15 minutes, this relearn process takes place, and you're ready to go. So people always ask me, hey, what tooling do I need? Well, it's dependent on the car fleet that you're servicing. Some of them only require a level, like if it has a radar sensor in the front of the car, the calibration may be a dynamic, but the initial is putting a level. So you can go down to your ADAS supply center, Lowe's or Home Depot, and pick up a level, and then go to town. You're able to service those vehicles. Now, if you move over to a lot of the Asian manufacturers, they're completely different, and most of those are requiring static type calibration. And static meaning you've got a special pattern that has to be placed at a specific coordinates in Z space. So the Z space would be out in front of that vehicle, specific Y and X coordinates. And once you place it in that specific space, you then use a scan tool to initiate that learn. Most of the service information provides the pathway to do all of that yourself. They give you the printout or the PDF of the little patterns, and you glue them together on a piece of paper, and you can hang them on a stick, and you put them right in place, and you can do that calibration. It will take a ton of time, but you can actually accomplish that. This is where the aftermarket has recognized these deficiencies in the way that you go about that, and they're building tools to increase that efficiency so that the technician can quickly and accurately place that target and the proper target right at the right position, and then engage with the scan tool into the vehicle and hit that and perform that calibration sequence. So it is, if you think about the bigger picture here, right? You've got perception systems on these cars that need to know and need to be able to understand the environment out in front of that car and help that car understand when it's entering a condition that might be hazardous to the vehicle. And our responsibility as service professionals is to make sure that those systems are operational whenever we're performing service on the car. And there are a lot of cars that go in for service. So say that they get maybe a timing belt service, and it goes into service mode and the whole front clip of that car comes apart. And that may actually have a radar module on that front clip. Front clip gets bolted back on the car. If you read in service information, it will ask you, hey, if this thing had a radar sensor on it, perform a radar calibration. Same goes with wheel alignment or suspension service. A lot of times it will say if the wheel alignment has been performed, you need to perform this after the wheel alignment. Maybe a 0-point calibration and maybe a calibration of the camera and or the radar. And I think a lot of folks are just, they're going through the motions of doing an alignment and then driving it and sending it out the door without looking at the details in the service information. So from the perspective of servicing today's vehicles, this is what I push a lot, is that we need to make sure that we're completely aware of what equipment is on these vehicles that we're servicing. So this goes for the people at the front counter. We've trained all of our folks at the front counter to always be looking out, and when they approach the car, they're doing a visual inventory of the car. There are visual cues that you can use to identify whether this car has certain things on it, which may impact the service operations that are going on with this car. And so when you're addressing these vehicles, you need to make sure that you're covering all the bases and performing all the right services, because again, we are in a highly litigious society, and the last thing we want to do is end up in court for something, performing a service that we've always been doing, and finding out that there's some safety system that was on this vehicle that didn't get reset or recalibrated after we did a service. That service information called for a specific operation to be carried out on. So this is where the training, knowledge, high situational awareness for the service professional comes in, so that we can, one, keep our customers safe and keep our business fine-tuned and operating smoothly.
How did you train your front desk people, or the folks that are doing the initial walk around, to be able to see what visual clues they should be looking for? Is it a checklist? Is it just being able to properly identify what it has?
Yeah, as vehicles are coming in, I would make observations on vehicles. We've got actually some fleet vehicles here in our loaner vehicles in our shop that actually have cameras. So we've had meetings, and we continue to update our meetings, and we walk around cars and see the new cars. I mean, some of the, like a backup camera for a Mercedes is hidden until you put it in reverse, and maybe the logo pops open and then a camera protrudes. So these are the things that we always cover, and we just do a walk around with our front staff, and we say, hey, this is how you can tell. The camera is pretty easy to see.
Sure.
But there are cues for radar. So you look at the front bumper, sometimes you can see that there's like a flat black plastic area where there is likely a radar module. You can then take a look at the steering wheel controls. A lot of times the steering wheel controls will have some indication that you have control over following distance. So that would be indicative of a adaptive cruise control type unit that would be supported by a radar sensor. But if you're working on a Subaru, Subarus don't use radar sensors. They use a stereo type camera system, which also we cover. So it's all about communication and maintaining that high attentiveness and situational awareness on the technology, because we see brand new cars come in all the time, right? We coach our customers into, hey, you got a brand new car. That doesn't mean you have to take it to the dealer for every oil change or every service. We can take care of those services for you and keep your car operating. So it's always about continuous education for us in our facility.
And I mean, that is a unique challenge in and of itself with operating as an independent shop, is trying to cover that, that broad, if you're a dealership and you're focusing on one brand, it's probably not that hard to identify all of those things. But if you're working on a bunch of different stuff, there's I think plenty of opportunity for training there, right? And being able to identify those systems.
Yeah, and the training, so we're doing internal training, but there's also external training, and we sign our staff up for training. This last year and a half, due to COVID, there's been a lot of virtual training opportunities, and I've got a classroom in the middle of the shop with a big screen that drops down. So we basically have been firing up that at lunchtime events and taking in classes. We've also got micro learning opportunities. We subscribe to a couple of services out there that the end user can log into their account, and I or management can basically take a certain group or a syllabus and put it together and say, hey, these are the things that I want this particular staff member to be in tune with, so that their proficiency is where it needs to be, so that their awareness is accretive to the shop's operation.
So that's kind of where I think the two paths between training and tooling intersect, right? Is that you can have all the tools in the world, but if you don't know how to use them, it's useless, right? And so I love how you say the micro learning opportunities, and even something as simple as having loaner cars that have some of that technology on it, because they're being driven and you can use them for your testing and for being able to kind of figure things out. What is the importance? And obviously I know the answer to this question in terms of why it's so important, but the importance of just a technician knowing the functionality of the tools that they have in general. And I think I asked that because I see it so often, and we use the scope as an example before, but that's not the only tool that people don't use to use the tool to its capability. Shops invest a lot of money in tooling, and I think that's going to continue to happen. But do you see a deficiency in techs fully grasping the capability of tools in general?
Well, it depends on who you're asking or who you're looking at. But, there are cases where I've seen tools being used in a creative way that I never even thought of.
Sure.
And the way that I learn about that, again, is through the microlearning. I've been microlearning my whole life by networking with or hanging around with people that are much smarter than I am. And this is basically how you learn, how you evolve your knowledge base. And you start seeing people demonstrating certain habits or certain processes. A lot of case studies out there, especially with the scope. I mean, there is a ton of stuff that can be done with the scope intelligently to, watch for certain things, watch for dropouts or what have you. But yeah, if you're hanging out in places, and it's really easy to do today, you go out on the internet and you find places. Diagnostic Network is a great place to do that. And you look at some of the case studies that technicians publish about, hey, this is what I had, this is how I got to where, this is how I figured this thing out. These are the tools that I used. And you look at it, you go, wow, I never even knew that tool could do that, or I never even thought about using it that way. So So yeah, it's pretty cool. But also there's trade magazines out there that publish a lot of this information and knowledge as well, and that can actually bring increase your situational awareness so that you're aware of some of these cool things, because there's a lot of smart people out there in this industry operating at different levels, thinking, hey, there's got to be a better way to do this, and hey, I'm all game for doing that. Just think about the the air ratchets we used to use, right? Have a nice air ratchet, and now they've got these battery operated ones, these electric electric ratchets, and now they've got these slim little necks on them, and you can slide right in there, and it's just amazing the evolution of technology around tooling, and of course, some of us become tool junkies, right?
Yeah.
and you see some of this cool stuff, you go, oh man, I'm going to use that, and yeah, you use it once in a while, but when you do go to use it, it saves you a ton of time, and that's what it's all about, getting the job done proficiently.
How do you, when we bring on a newer tech, right? So saying somebody that is just leaving tech school and is coming in and is still kind of getting their feet wet, and this is again kind of a broad question in the sense that there's just so many different skill sets out there, just different levels of skill. And one of the things that I always kind of struggle to get my hands around is you bring this person in, they've learned a lot throughout the course of their tech training or tech school training. But the things that they learned might not actually be at that capacity to be able to use that tool adequately. How do you bring somebody in and not overwhelm them? And getting them to buy into diagnostics and understanding systems and everything like that. I think it's one thing to learn it in a program, and then how do you really, from a shop management standpoint, onboard them properly so you don't overwhelm them?
Yeah, well, I think first and foremost, you're bringing them into a production environment where absolutely the customer's vehicle being properly serviced is the first point of order. So when you bring in a new technician, somebody that's new, you're going to have high level of supervision. You're going to have them checked off. We've got some processes in place here that when we do have somebody new, or we have an apprentice that's doing a new task, before, during, and after, we are getting some checklists in place so that operation is done properly and that it's signed off on, so that it's back together and that everybody knows how to do it properly. Because the last thing you want is bad habits or shortcuts that are going to compromise that vehicle's integrity. And and it's tough because it's almost everything you touch on a car. When you go to take certain things apart, you have to be very careful that you don't damage things. And knowing where to press or where to pull is very critical so that these things don't break. But yeah, establishing some processes and procedures inside of your facility around these service operations will help to ensure or minimize any risk of negative outcomes. Torquing wheels, that's probably one of the biggest concerns, or torquing components in general. But proper disassembly, assembly, clean work environment, just make sure that they've got all the tools, equipment, and the environment that's conducive to producing a positive outcome. And I think that you'll end up with a positive result.
Yeah, and it's funny because I think, again, this comes from my personal experience, but I remember going through tech school and then the instructors talking about, it was almost, you had the fear of death in the fact that you could fry a controller and the amount of money that a new controller costs. And this is 20 years ago, but I was terrified by that part. And like then coming into the shop atmosphere and then getting that reemphasized by a service manager and saying, you know, you put power to this in the wrong spot, you're going to fry this controller. And, you know, I think that's where a lot of people, and I could be totally off base on this part, but I think that's where some of the intimidation comes in too, is where if you're afraid of frying a controller or screwing up a component, that can be almost paralyzing to the fact of like diving in and really truly being able to understand it. And so I don't know if you'd have any advice for young techs out there in general of a good way to approach that.
Yeah, it's you know, as you were talking about the power, you know, there have been cases out there. I've heard these stories where a car's battery was dead, completely dead, and somebody went to jumpstart it, and even though they hooked the cables up properly, it ended up causing a module problem on that car. So you know, the proper way to do it would have been to take that battery out of the car and put another battery into the vehicle. So you know, these are things that you need to reference service information. Whether or not that particular case that I just mentioned had a procedure outlined in service information about jumping it or what have you. But you know, we've seen cases where cars have come in and you can actually see the top of the cable had a reverse polarity condition, you know, either maybe a tow truck or somebody else tried to jump it and they got the cables mixed up. Yeah, and that's disastrous for these vehicles that are laden with, you know, multiple modules. Yeah, that is very intimidating. But and usually, you know, a new personnel coming into the marketplace, they're probably not going to be initially working on the diagnostic end of things. At least not what we've experienced here today. We you know, they may be doing some diagnostics on, you know, charging system operation, but not doing full-on drivability or emission control, fuel control type failures. So they're getting their feet wet on some of the baseline elements, or getting comfortable with the vehicle, especially when you're working in the aftermarket. I mean, I think the challenge is even higher because you're typically working on a much wider year range of automobiles and a variety of brands, right? Versus say working in a dealership, you're working on probably a smaller subset of year models and mostly new vehicles of the same manufacturer. So things become a little more common, you know, and what have you. So just getting familiar with around a vehicle, moving, say, disabled vehicles, you know, because cars come in disabled, they won't move, car won't come out of park. How do you move that vehicle around properly? Those are all the things that you begin to learn as you gain experience working in a production facility.
Yeah, I think I loved what you said about having kind of processes in place for a new technician so that there are things to check off and there are things to kind of follow. I think that helps a lot. I want to shift to the future of the industry in general, and this could probably be an entire podcast on itself, but I think it helps paint the vision for a lot of what we're talking about and how we strategically plan to attack some of the new technology coming. One of the things that it was funny, I think was on YouTube a few weeks back, and there was a video about the future of automotive shops, and it looked more like a laboratory than it did like a shop, right? It was very clean, and you could tell they ran a really nice operation. But I think there's some general concern that with these parts, you know, a lot of the moving parts going away, or a lot of the wear parts going away, where does that leave the service industry as we move forward? And what are there for opportunities moving forward when you don't have oil changes and you don't have, you know, some of the basic maintenance that we've been accustomed to for many, many years? what do you see yeah, oh, sorry, go ahead, Scott.
Yeah, I mean, I get where you're going, and this is definitely a point of order that needs to be addressed. Yeah, we're changing. This landscape is evolving, right? Even the point of people owning a vehicle is coming into question, right? Are people just going to go into rideshare or what have you? There's subject on both sides, right? So if you've got a rideshare type environment, you've got vehicles that are going to have a very high duty cycle now. And so things are going to wear, right? You're still going to have tires, you're going to have chassis components that wear. You're probably going to have window motors and other electrical things going on with the vehicle that require service. And of course, you're going to have somebody that can diagnose those failures. But on the other side, the own things, right? Most cars are basically sitting for 95% of the time, right? So they get driven short trips or what have you, but they're getting high levels of equipment being added to the vehicle. My position is that we need to be experts at all of these high level systems and have a sharp awareness of how these all work and operate, because these consumers, when they buy these automobiles, they are not getting trained. In my opinion, they're not getting trained properly so that they understand exactly how these systems are operating. And we, as a trusted individual, demonstrating the fact that we've got high levels of competency in how these operate, and we can be trusted to ensure that they are operating properly, and we're the go-to person for service. That's how we can ensure that we are still part of that ecosystem in the service environment. But yeah, we're going to need to be able to figure out ways to become more sticky, right? A hub for addressing challenges, whether it's charging, right? So if these vehicles are becoming more electrified, maybe your service facility then becomes a hub around, you've got charging, especially that's nice if you're in locale to like a downtown area or a shopping area or some other point of interest that people can park and then go do other things. So yeah, it's definitely, the aftermarket has always evolved, right? We've always adaptive, we've always improvised. You just need to make sure that you're paying attention and you're looking at what's coming down the pike so that you can be as prepared as you possibly can.
So this is a question that I genuinely don't know how to phrase this, but in a lot of ways, I think a lot of shops, both on the dealership side and the independent side, got very comfortable doing maintenance, right? Because I think maintenance was it was a predictable repair. It wasn't like diagnostics where it can go a number of different ways. And so the preventative maintenance part of a business was really attractive. And I've seen a lot of shops adapt to that, to where, they maybe don't love doing the big engine jobs or the big transmission jobs that they used to. They have found that there's good business in maintenance. And so I think one of my concerns for both the dealer side or the OE side and the aftermarket is it almost feels a little bit like we're moving to heavy diagnostics, heavy tires. Am I off base with that?
Well, I think, the maintenance is still going to be there. I mean, even if you look at an electrified vehicle, you've got maintenance, you still have a hydraulic brake system, right? When that vehicle goes into a automated emergency braking event, right? So say that it's going to possibly run into something that's going to stop the vehicle. The hydraulic brake system is very critical. As you know, brake fluid is hygroscopic, and over a period of time, that brake fluid can break down, lose its properties, gain moisture content, and there is a service interval. And we practice this in the shop. we measure it with a specific device that helps us understand what the health of that fluid is. There are some manufacturers that require it to be replaced in certain intervals. So you want to make sure that you're staying on top of all of those maintenance items. The refrigeration system is crucial too, because power electronics require thermal management. And so it's not only, the thermal management is not only with the refrigeration system, but it is also with a coolant loop. And some of these cars may actually have multiple coolant loops, and that fluid may require replacement periodically. And when you do that replacement, there's usually a procedure to make sure that you get all the air out of the system and so on, and that it's functioning properly. I think that on the diagnostic end, you're going to have some failures. We don't know, right? There's a lot of unknowns to predict on what's going to happen. But you're going to have a keen sense, like we talked at the beginning, the software technicians that have a sense of how software operates and failure modes, electronics background. Those are all going to supplement the diagnostician and have them best prepared to address those challenges. And even network communications. I think that's another big one that I'm seeing, because even though you may have a factory scan tool to communicate with the car, there may be more information there than the scan tool is actually offering. And so having that extra knowledge around how to interpret maybe additional CAN messages or Ethernet messages or what have you, maybe to get a clue, go out and look at what the job description or job requirements are for, say, a field service engineer for an auto manufacturer, one that goes around to different dealerships to troubleshoot the really hard problems. You will see a list of interesting, unique skills that these individuals need to have. And I think you'll find them very interesting. Some of them I've already dove into to learn about, because yes, there's quite a bit more information that you can gain out of a car if you start peeling back some more layers.
This is fascinating. This is really, really good stuff. I don't know that I've ever had to have this much focus on a podcast before to make sure that I'm following everything and making sure that I'm taking good notes. One last question on the maintenance side. Will these batteries have any level of maintenance, or is it just kind of replace, or is there opportunity for maintenance on the battery side?
Yeah, I think that's subjective. I think for the most part, the auto manufacturer, the manufacturer of the battery, they are really keen on making sure that the battery is in a good state of health at all times. So when the battery is going through a recharge process, they are typically, you've got multiple cells, right? Some of them are hooked up in series, some are in parallel. And you want to make sure that those cells are at the same voltage potential at all times. So when you're charging, there's typically cell balancing going on, and the manufacturers have different ways of shunting and controlling that. When the technician's looking at scan tool, that's one of the PIDs to look at, is the highest cell voltage and the lowest cell voltage, to understand what's going on. And you can monitor that during certain load conditions, right? When you're accelerating or you're decelerating and regenning, to try to get some idea of whether there's some anomaly going on there. So some cars can actually be charged at a higher rate, at a fast charge, and then some can be charged at a lower rate. In my opinion, the high rate charging, it should be done only when necessary, and the low rate charging is really where you're going to get the best longevity out of a battery. So as far as the maintenance goes, I think that just treating the vehicle properly, having a high level of knowledge, and this is where the service provider, I think, can then coach the vehicle owner that doesn't know all about this stuff, and perhaps even hosting some classes to help educate them and demonstrate the fact that they're highly knowledgeable about how these systems work, and helping their customers understand that how to keep the battery life at its optimum. But tell them that maintenance is critical. In some cases, there are filters that may be required to be replaced. Some batteries are air cooled. If you look at the hybrid vehicles, Toyota Prius, they've got filters for the fan, the inlet fan, that sometimes people don't pay attention to, and that filter can get plugged up, and it can put that coolant system, that fan blowing apparatus, in a deficient state, and it can lead to premature battery failure. So these are all things that the service provider needs to be aware of to make sure that that vehicle is getting the proper service and attention.
I tell you what, if you didn't learn something off of this podcast, you're missing out. I think you might want to re-listen to it. This was outstanding, and I thank you so much for taking the time today, Scott. What you've done for the industry, I feel like is unparalleled. You've done some really, really cool things, and are continuing to do those. So if for those of the listeners that would like to reach out to you, how does somebody get in touch with you?
They can go to Diagnostic Network, or my email address is sbrown, my last name, S as in Sierra, Brown, BROWN, @diag.net. And you can ping me there, and you can go. I'm highly visible out there. You go to LinkedIn, you can look me up. So I'm highly available.
Yes, you are.
Thanks for having me.
Oh, thank you so much. And I do have to give a shout out. I think you posted a video yesterday on LinkedIn of some testing that you were doing with a target, essentially, or you'd have like a person or the back of a car, like the cutout. That was the coolest thing. Like, for a visual, that was awesome.
Yeah. So what we did there is that we had that was a week-long training, a train-the-trainer at Victor Valley College up in Victorville. And they had acquired two typical test apparatus. One of them is the back of a vehicle, simulates the back of a vehicle. It actually has some radar reflective devices inside of it, and it looks just like a vehicle. And so we ran several tests on vehicles and let all the student instructors observe automated emergency braking, how the systems operate, how sometimes they don't operate. And then we also had a pedestrian, right? So a pedestrian that would typically, it was on a little skateboard, but we didn't have any movement on it. But normally you would move it across the vehicle's path as it was going. And the car would, then if it had the right equipment, have, identified that object, and then push out protective measures, right? Address the braking. In some cases, the vehicle might actually steer itself or what have you. So yeah, we had some fun with doing all that demonstration. We were recording video. I recorded some video when I was in the car. And so we played around with it a little bit. And then in the very end, if you go out and look at that video, you see the very end, we strapped the camera or the phone to the pedestrian, and we had a failure where the Lincoln actually ran into the pedestrian. The phone flipped off, and then we finished it up with making it look like it actually ran over somebody. So we had some fun.
It looked like a lot of fun, and I think if those of you, I would encourage everybody to go follow Scott, to go out to Diagnostic Network. The platform that he's built out there is outstanding and incredibly beneficial to those techs that want to take it to the next level, being able to do the networking like Scott talked about earlier in our podcast. There's so much impact in that. There's so much benefit in that. So again, thank you, Scott, for joining us, and hopefully you'll see some of our audience out on Diagnostic Network, because I think it's one heck of a good tool and something that continues to grow and just adds value to the industry as a whole. So thank you so much.
Great. Thanks. Glad to be here, and happy to do another session in the future.
We will take you up on that. I can guarantee that.
All right.